just briefly, all this is just QVB and bias of R. Actually, it's QV cross B, and it's equivalent to IL cross B, right? That tells you how you get magnetic fields. It tells you how what magnetic fields act on. So really, it's pretty much all magnetism. Okay? It all comes from this. Now, I'm exaggerating. It doesn't quite all come from this. Okay? Things like displacement current and other types of flux change and stuff we have to worry about later. Okay?
What about Maxwell's equations?
Well, that's what I'm talking about. I mean, these are just somewhat special cases of Maxwell's equations. Okay? But Maxwell's equations are stated in quite more general form in the language of multivariable calculus. Okay? Okay, on a coil you add torque to the mix. Torque is some other R times F, right? And F is typically the force on a segment, small segment, like if you got a loop like this, okay? Now if you got a uniform magnetic field, then force on each side, you can write down the exact quantity for it. But here, your segments are at different angles and different distances from the axis. So you have to do integrals or invoke superstition, which is the results of the integrals without doing the integral or setting it up. That would give you a torque on a loop. Okay? Of course, you can always do the magnetic field of the loop. That again requires integration, but we did that early in the course for a field at the center of a circular loop, which is something you should have locked in. Okay, make sense? Okay, well, let's look at some other constellations.